Section 4-6 talks about congruence in right triangles. Okay, so let's first talk about right triangles. A right triangle are triangles with one angle of 90 degrees. In a right triangle, the side opposite the right angle, so let me draw a right triangle here. So there's an angle of 90 degrees. The side opposite the right angle is called the hypotenuse. And the other two sides are called the legs. So here's the right angle. Opposite it is the hypotenuse, and next to it are the legs. So when we have a right triangle, we can use the hypotenuse leg theorem, or HL. We have already looked at, for general triangles, angle side angle, side angle side, side side side, and angle angle side. So those are the four that we can use with a general triangle. With a right triangle, we can use the hypotenuse leg theorem. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. In other words, if I have right triangle A, B, C, and right triangle D, E, F, if BC is congruent to EF and AC is congruent to DF, then the triangles are congruent. It's important to note that we call this hypotenuse leg theorem, not side-side angle. Side-side angle does not work, and I'll show you why in a little bit. But right now, keep in mind that this is a right triangle, and we are using hypotenuse leg. Okay, let's go back and let's do a quick theorem using hypotenuse leg, or a quick proof rather. Let me go ahead and erase the ink here. Let's say that we have this drawing, and we have a right angle here, and we have a right angle here, and then we have a line passing through here. And I'm going to call this A, B, C, D, let's do D here, D, E. And we are going to be given that BE bisects AD at letter C. We are also going to be told that AB is perpendicular to BC and DE is perpendicular to EC. And the last given is that AB is congruent to DE. So those are all given statements. So we have perpendicular lines here and here. We have DE and AB congruent, and we have C as a bisector. So if we say that angle B is congruent, well, let's first say that angle B, where's my eraser, and angle E are right angles, and that's because perpendicular lines form right angles. And then we can say that angle B is congruent. Well, we don't even have to say that. We can say that triangle CED and triangle CBA are right triangles. Okay, and that's because right triangles have a right angle, definition of a right triangle basically. And then for 4, we can say that AC is congruent to DC, and that's because that's the definition of a segment bisector. And finally, we can say that triangle CED is congruent to triangle CBA by the hypotenuse leg theorem. Okay, so we showed that these two were congruent because of the bisector, and then because they are right triangles, we can use hypotenuse leg. Okay, all right, so I told you earlier it's important to note that this theorem only applies to right triangles. We cannot assume that side-side angle will work for other triangles that do not have a right angle. So for example, if I have a triangle that has a 45-degree angle, and one side is 5, and then I have another triangle with that same 45-degree angle and a side of 5, and then I have another side. Now if that other side is, let's say, 6 units long, and it could go here, or it could, I'm sorry, it has to be less than 5. Let's say 4 units. My picture is getting really bad. All right, let me try again. Hold on, let me try this again because I'm making a mess. Okay, so let's say we have a 45-degree angle, which looks more like that. That's better. Okay, and this 45-degree angle is the same on both. We also have a side length of 5, and then we have a side length of 4. So there are 2 ways that that side length of 4 could join up. It could come up this way, or it could come down this way. So you can see that on these 2 triangles, we do have a side and an angle that are congruent, but the triangles are not. We'll talk about this more in class, but that's it. Hypotenuse leg theorem for a right triangle.